Hello. Am I audible?
Yes, sir.
Yeah. Yeah. Alright, do you have any doubt from the last class? Samira?
No, sir. But I have doubt in the assignment.
Okay, just ask.
Okay, well, 1 minute, sir. So the third question, the physical quantity having the dimensions m raised to -1, L raised to -3, T raised to -3, A raised to A raised to 2.
This one?
T raised to 3, sir.
M raised to the power -1, L raised to the power -3,
Yes, sir.
and T raised to the power +3,
Yes, sir. Yes.
and A raised to the power 2. Tell me
Yes,
the
sir.
options.
The options are resistance, resistivity, electrical conductivity, electromotive force.
Okay. As we know, resistance is equals to rho L by A. Okay.
Yes, sir.
We have dimension of this particular resistance, which is nothing but voltage upon current. R is equals to V over I.
Yes, sir.
And for voltage, which is M L square T raised to the power -3, A raised to the power -1. Upon I, so it will becomes -2. This would be the dimension formula of resistance. Rho,
Yes.
we have to calculate. L is nothing but capital L, and L would be L square. So it will be rho is equals to M L square T raised to the power -3, A raised to the power -2, divide by L and multiplied by L square. So in total, it will becomes M L to the power 3, T to the power -3, and A to the power -2. This would be your dimension for resistivity. As we know, conductivity is denoted by sigma, which is nothing but reciprocal of resistivity. So if just take the reciprocal of this whole part, it would be m to the power -1, L to the power -3, T raised to the power +3, and A raised to the power +2. Is it the same thing?
Yes, sir.
So this particular sigma is nothing but conductivity, or we can call it as electrical conductivity. This rho is nothing but resistivity or electrical resistivity.
Yes, sir.
Any more doubt?
Yes, I have.
Tell me. Yusra Khan.
Question 9. L, C, and R represent the physical quantities, inductance, capacitance, and resistance, respectively. The combinations which have the dimensions of frequency are: option A is 1 by RC, option B is R by L, C is 1 by root LC, D is C by L.
Since we have already done the dimension of LCR, okay? We have done in our last class the dimension of LCR. If you put the dimension of these two terms, it would comes out to be T raised to the power -1. The dimension of this whole part would be just this. If you calculate the dimension of this part, it would be T raised to the power -1. Similarly, if you can calculate this particular term, it would again be T raised to the power -1. But it would have something different dimension other than this whole. And as we know, frequency is nothing but reciprocal of time period. Okay. So if you take the dimension of this particular part, it would be nothing but T raised to the power -1. So for frequency, dimension formula would be T to the power -1. So for this part, and this part, all would represent the same dimension, that is the dimension of frequency. But this part is other than this particular whole combination, so it will be neglected. Okay, so what are the options? So we have multiple options or more than one correct option in this question. Okay.
Okay, sir.
So all of the three options, options A, option B, and option C would be correct.
Okay, sir.
Safan, any doubt from the last class?
No, sir.
Have you done your assignment?
Yes, sir.
Have you done your assignment?
No, not yet.
Why so?
I'll do it today.
Good. So should we start with today's topic? Samira?
Sir, I have one more doubt.
Okay, just ask.
In the 11th question, what is the dimension formula of capacitance? Because in last class we did, but there is no option in the column 2.
Okay. Suppose for capacitance, you can write it as Q is equals to C times V. So C is equals to Q divided by V. Or you may solve it by energy is equals to half Q square over C. So C would be Q square divided by 2 times of E. On putting their dimension, it would be A raised to the power 2, T raised to the power plus 2, divided by E, which is energy, ml square T minus 2. So if you bring them towards numerator, it would be m to the power -1, a to the power -2, T raised to the power 4, and A raised to the power 2. So this would be your dimension for capacitance. Is there any option?
No, sir. It's like m raised to -1, L raised to -2, T raised to 2, and Q raised to 2. What is Q?
So it was written in terms of charge. So in terms of charge, you may rewrite it as m to the power 1 -1, L raised to the power -2, T raised to the power -2. But in place of this whole part, just write it in terms of Q as well. So it would be Q raised to the power 2. Okay.
But in the option it's written T raised to 2, not -2.
It would be just T raised to the power plus 2. If you bring this particular T to the numerator, it would become positive 2.
Okay. Thank you, sir.
Depending upon the question, in what way they have asked, you have to answer accordingly. Okay.
Okay, sir.
So we have just done dimension formula for different quantities. We have two more formula related to this particular term. First one is permittivity, and the second one is called permeability. Permittivity is defined with the word permit. Permit means allowance tendency of a particular medium. Means the tendency of a medium which allows or restricts the electrical interaction between any two point charges is defined by this particular word, which is called permittivity. So for this particular permittivity, we use a Greek alphabet, epsilon and naught. So this is called permittivity of vacuum, or we can call it as permittivity of free space or absolute permittivity. Similarly, if there is magnetic behavior in that particular medium, so it would defined by a Greek alphabet mu and naught. So we can call it as permeability of vacuum. These are just two terms. So for this particular part, there is a formula. Force is equals to 1 by 4 pi epsilon naught q square divided by r square. We already know the dimension formula for force, dimension formula for charge, and dimension formula for distance. From this, we can solve it by epsilon naught is equals to q square divided by 4 pi f times r square. Is it clear? Safan?
Yes, sir.
Okay. Similarly, for this particular epsilon naught, there is a relation. C is equals to 1 by root under mu naught epsilon naught. C is nothing but speed of light. And speed is nothing but Lt to the power minus 1 in terms of dimension. So just try to find epsilon naught from the left part, from this segment, and put it to here and try to obtain for this segment. Okay? Samira, any doubt?
No, sir.
Okay, just try to find out. Yusra Khan? Safan, any doubt while solving?
No, sir. 1 second.
Okay. Good, Samira. Try to solve the next part, that is for mu naught. Yusra,
Yes, sir.
are you solving or do you have any doubt?
So what exactly should we do? Because I joined a few minutes ago.
We have to solve for this particular epsilon naught. So just put the dimension formula for charge as we have already done in our last class. Dimension formula for force and dimension formula for this particular R, which is nothing but L. Okay,
Yes, sir. Okay.
good, Safan. Myra, check the exponential of L and T. Yusra, just see this. We have to put the dimension formula for this charge, which would be nothing but A and T, and squared over it. Divide by 4 pi is nothing but any constant. So in terms of dimension, we can neglect them. We're left with just force. So it would be mLt raised to the power minus 2. R is nothing but length. So squared of it. On bringing all terms to the numerator, it will become n to the power minus 1. L to the power 1 and L to the power 2 becomes L to the power 3. And on bringing to the numerator, it becomes minus 3. Similarly, we have t raised to the power minus 2 in denominator. So on bringing to the numerator, it becomes plus 2. And we have already t to the power plus 2 in numerator. So it will become t raised to the power 4. And the last part, it would be A raised to the power 2. Okay, Yusra?
Yes, sir.
So next part is we have to calculate this particular mu naught, which is nothing but permeability of vacuum. So first we have to simplify this particular equation. There is square root in this section. So just square over both sides. So it will be c squared 1 over mu naught epsilon naught. On bringing this particular to the other side, it will become mu naught is equals to 1 by c square epsilon naught. Now just put the dimension of c as LT minus 1, epsilon naught as this one, and try to simplify it.
Okay, sir.
Sir, is C capacitance?
C is here speed of light, which I have just written L t to the power minus 1.
Okay. Sir.
Good, Safan. Good, Samaira. Have you done? That's all. Just see, we have c squared. C is nothing but L t to the power minus 1. So it would become L square t to the power minus 2. If epsilon naught is m to the power minus 1, L to the power minus 3, t raised to the power plus 4, and a raised to the power plus 2. So on bringing all term to the numerator, it will become m to the power plus 1. L to the power, here we have minus 3 and here we have plus 2. So it will be left with just minus 1. On bringing it to the numerator, it will be L to the power plus 1. Next part for t, we have t raised to the power 4 and we have t raised to the power minus 2. So it will be t raised to the power plus 2. On bringing it to the numerator, it will become t raised to the power minus 2. And last, a raised to the power minus 2. Okay, Yusra?
Yes, sir.
Okay. So we have just defined all the different dimension analysis and dimension analysis term. The next part is to define property and application of this particular dimension analysis. For this, let's first define principle of homogeneity. You must have learned this particular homo in various sections in your earlier classes, like in class 9th for mixture, it was homogeneous mixture. Similarly, in class 10th for carbon compound, it was homologous series of different compounds. Similarly, in bio, there was a topic that was homologous organ, and similarly so on. So homo means in all of the cases, nothing but same or similar type. So in this particular term of principle of homogeneity, it tells you nothing but, suppose when you have started learning algebra in your mathematics, if there would be 3x square minus 2x plus x square and plus 5x. And if we have to simplify this particular expression, how would you start with? Just see 3x square and x square. So we can call them as like term. So we have just defined there only like terms will be added or subtracted. Since this particular term containing x square and this particular term containing x square, so these two can be added together. So it will become 4x square. Similarly for this part and this part, these two terms are containing x and x. So we have minus 2x and plus 5x. So it will become plus 3x. So the idea behind this term is nothing but like terms will be added or subtracted. Similarly, in physics, if two quantities would be added or it has to be subtracted or equated, these three operations between any of the two different quantities would be possible only if they contain same dimension formula or they resemble same dimensional quantity. Then it would be possible to add, subtract, or equate. Otherwise, it would be meaningless. Is it clear?
Yes, sir.
So we can define this particular term, principle of homogeneity, as two physical quantity can be added, subtracted, or equated only if they have same dimensional formula. So if A plus B, A minus B, and A is equals to B is written. In all of these three different relationships between A and B would be possible only if A and B having same dimension. Otherwise, it would be meaningless. Is it clear to everyone?
Yes, sir.
Yes, sir.
Safan, any doubt?
No, sir.
So on the basis of this, let me give you a question. If P is equals to A divided by B square bracket B minus P is equals to C. Here we have P is nothing but pressure, B is volume. We have to calculate dimension of A, B, and C. So how to proceed this particular problem? Just see in this particular first bracket, there is two different quantity. First one is P and the second one is A over V square. And there is a relation between them as plus sign. We have just defined if two quantity are related by plus, minus, or is equals to, this particular relationship would be possible only if both quantity contain same dimension formula. Otherwise, it would be meaningless. So from this, we can say this particular quantity P and this particular quantity A over V square must be equal in terms of dimension. So dimension of this particular P and dimension of this particular A over V square must be equal. Is it clear?
Yes, sir.
Now just see this particular equation. We have P as pressure, for which we already know the dimension formula. Next, V is nothing but volume, for which we know the dimension formula. And the next part is A, which is the variable in this particular equation. So try to solve A for this part. Similarly, just see the next bracket, that is this part. What we can conclude about the dimension formula for B? Yusra,
Yes, sir.
what you can say about the dimension formula for B from this expression? Just see, we have two different terms. First one is volume and the second one is B, and they are related by nothing but negative sign. We have already defined in terms of principle of homogeneity, if two quantity are related by negative sign, it means the two quantity would be representing same dimension formula. It means volume and B must be of same dimension. Is it clear?
Yes.
Safan, any doubt?
No, sir.
Okay, then put the dimension of each part and try to solve for A and B. Samara, any doubt while solving?
Sir, can you solve?
First part, let we have P is equals to A over V square. So on resolving, it will become P is equals to P V square. And we already know the dimension formula for P is n L to the power minus 1 T raised to the power minus 2. Volume is nothing but L cube. So squared over it. So it will become L to the power 6. We have L to the power minus 1 here and L to the power 6 here. So on solving, it will become L to the power plus 5 and T raised to the power minus 2. Is it clear?
Yes, sir.
Yusra?
Yes, sir.
Similarly, for this particular expression, B would be equals to the volume. And for volume, the dimension formula would be nothing but L cube. So B would be just L cube. So from this, we have concluded the dimension formula for A and B. Now, how to solve for this particular third part, that is for C. First of all, write it down. Have you all written?
Yes, sir.
Samira, done?
Yes, sir.
1 second.
Samara, is it for C? Just wait, I'm solving for that. Safan, done?
Yes, sir. Done.
Okay. So the next problem is how to solve for this particular C. We have relation A divided by B square in bracket V minus B is equals to C. Suppose if you have to add 2x and 2x, it would be nothing but 4x. Similarly, 3x minus 3x would be Safan. 3x minus 3x would be
0.
on adding or subtracting only coefficient changes. But its variable term, that is x and x, remains same. So 3 minus 3 would be 0 times x. And if you multiply it 0 with any of the number, the whole term would becomes 0. Okay? Similarly, L plus L would be nothing but 2 times of L, and L minus L would be nothing but 0 times of L. In terms of dimension, this particular number 2, 0 represent nothing but dimensionless constant part for which there is no dimension. So we just neglect this. So we're left with nothing but L. Similarly, 0 is any constant number, so we can neglect it. So we're left with that nothing but L. So from this, we can conclude L plus L would be equals to L, and L minus L would be equals to L. But this relation would be valid only in terms of dimension. Is it clear? Samara, is it clear?
Yes, sir.
Similarly, if you try to solve this particular part, let's say we have this P, nothing but pressure. So this quantity must be representing nothing but pressure because they are related by some plus sign in between. So first quantity and second quantity must be of same kind. Similarly for this part, since it is volume, so this part must be defining you nothing but volume. Now just check. This part is pressure, and this part would also define you nothing but pressure, and there is plus sign in between it. So what we can conclude from this, P plus P would be nothing but yes, Samara. P plus P would be Safan
P plus P,
would be equals to
2P.
and 2 is any number, so we can neglect it. So what we left with
P.
good. Similarly, for this part, this is your volume and this must be your volume. So V minus V. So what would be
V.
good? And what's the mathematical operation between any two vectors? It would be multiplication is equals to nothing but C. Now, from this relation, you would be able to calculate the dimension formula for C. Is it clear, Sumaira?
Yes, sir.
Yusra?
Yes, sir.
Okay, just try to solve. Good, Safan. Yusra, just see here, it is just P, for which dimension formula is nothing but mn to the power minus 2. And V is nothing but volume, so it would be L cube. So we have to multiply these two terms. So Myra, have you solved? Good. Yusra? Good. You may write your answer as M, L, T like this, instead of taking the exponential. Okay, Yusra? Okay, so we have just
Yes, sir.
defined principle of homogeneity. The next part is, there is some term, suppose sine of x, exponential x, and log of x. Whether it would be sine, cos, tan, or any of the trigonometric function, this particular x would define you nothing but angle, because sine is defined for any of the angle, sine of 30 degrees, sine of 45 degrees, and so on. This is exponential function, so x in this particular exponent would be nothing but any number. Similarly, log is defined for only positive number. So from this we can say this x in this expression will define you angle. This x and this x would define you nothing but number. Whether it would be angle, it was dimensionless variable term. So it was nothing but dimensionless quantity. So whether it would be angle and whether it would be any number, these two will define you nothing but dimensionless. For the case of dimensionless quantity, we can write as m to the power 0, L to the power 0, and t raised to the power 0 for its dimension. And we already know about it. If a number containing 0 exponential, its value would be nothing but 1. So for any of the quantity which is dimensionless, put the dimension of those terms to 1 and try to obtain the rest of the part which is variable in that particular expression. Is it clear?
Yes, sir.
Yes, sir.
So in these three examples, x is defining nothing but any dimensionless quantity. Similarly, if we take the value itself, sine of x, e raised to the power x, and log of x, this whole part, sine of any angle, this whole part, exponential of any number, and this whole part, log of any number, would define you nothing but a fixed number. So these three would also define your number, and number again would be dimensions. So whether this particular angle and whether this particular whole value, these two would define you nothing but dimensionless quantity. In terms of mathematics, we call these terms as argument. So we can conclude from this particular expression whether their angle or whether their argument both will be dimensionless term. So put the dimension to be 1 and try to obtain the rest of the part. Okay? Is it clear?
Yes, sir.
Safan,
Yes, sir.
I'm giving one question how to solve on the basis of this particular part. If suppose y is equals to a sine, or you may take as cos, tan, or any other thing, cos b of x plus c of t. In this expression, x and y is defining nothing but displacement. T is nothing but time. We have to calculate dimensions of A, B, and C. So how to approach this particular problem? Just see. Here we have for first part, this bx and this ct. What we can say about these two terms? So Myra, which quantity would be represented by this particular bx and ct? Savan,
Yes, sir.
which quantity would be represented by this particular bx and ct? Just see, here it is cos. So it is defined only for any angle, as we have already defined it, like sine of x. Okay,
Okay, sir.
so we can say this whole part bx would define you nothing but angle, and angle is nothing but any dimensionless quantity. Okay, and for any other dimensionless quantity, we just relate it or equate it to 1. So from this, we can say bx would be 1. Here, x is nothing but displacement and b is any unknown part for which we have to solve dimension. So we can write b is equals to 1 over x, or we can write it as 1 over l. If we bring that particular l to the numerator, it will be l to the power minus 4. Is it clear? Yusra,
Yes, sir.
Safan, is it clear?
Yes, sir.
So just tell me what we can say about the dimension of this particular C and T. It would be equals to Safan.
Yes, sir. CT is equal to 1.
Good. As we know the dimension formula of T, so just put the dimension and try to obtain for C. Okay. Just write it down and try to solve for C. Samira. Just check your exponential of whether it would be positive one or negative one. Good, Safan. Good, Yusra. So C would be equals to 1 over T, or you can write it as T raised to the power minus 1. Now we have solved for both B and C. The next part is to solve for A. So just see this whole part. This whole part, cos of any angle, would represent you nothing but any number. So on the base of it, we can neglect this whole part, as this whole part cos of any angle would represent you nothing but any number, and number is any dimensionless constant part. That's why just neglect this whole part. So what we left with? Nothing but A is equals to Y. Here Y is nothing but displacement. So it would be capital L. Is it clear?
Yes, sir.
Yes,
Yusra?
sir.
Okay.
Yes, sir.
So we have just defined on the basis of principle of homogeneity how to obtain the unknown part, whether they be dimensionless or not. Okay, I'm giving you one more problem. Have you all written this? Safan?
Yes, sir.
Yes, sir.
Just solve this. If force is equals to A divided by X plus B divided by V. In this, F is defining you nothing but force, X is defining nothing but displacement, V is defining nothing but velocity. Try to find dimension of A and B. Let me give you some hint regarding how to solve this part. Just see, we have two different parts. First is A over X and second one is B over V, and they are related by any plus sign. So according to principle of homogeneity, it tells you if two quantity are related by some plus sign, it means the dimension of these two terms must be equal. But just check this particular equation. This is just one equation and having two different variables, just as A and B. So we can't solve two different variables using just one equation. So this relation would be neglected. So there is another relationship between these two terms. Just see, this whole part is in equals to with this particular force. So you can either equate each of the part to directly this particular force to directly this particular force. So it would be F is equals to A over X, or F is equals to B over V. We already know the dimension formula of force and displacement. So from this, you can easily solve for A, and from this, you can easily solve for B. Is it clear?
Yes, sir.
So depending upon the question, we have to apply different concept regarding that particular problem. Okay, just try to solve for A and B.
Sir, what will we substitute in place of X?
X is nothing but displacement, and displacement is nothing but length. So its dimension would be capital L. Try to remember all the dimension formula which we have done in our first class. I've given you, I think, 12 or 13 relationship. Yusra, just check again. Here, X is in denominator. On bringing it to the other side, it would be in multiplication with this particular force. Sumara, have you solved?
What I'm doing.
Safan,
Yes, sir.
doing?
Yes. Sir, in place of velocity,
It would be LT minus 1.
LT minus 1.
Yusra, we checked your calculation. Good, Safan.
Sir,
Yes,
when it like the L, the one for the displacement, if it's in the denominator, then when it goes to the numerator, the exponent will become negative, right?
no. This is just multiplication of this particular term. I'm not changing the numerator denominator term to the numerator. I'm just shifting from one side of equation to the other side. Okay.
Okay.
So on simplification, it would be A is equals to F times of X. We are not shifting the denominator to numerator or numerator to denominator. We are just taking cross multiplication of them.
Okay, sir.
Similarly, you can write B is equals to F times P. Safan, check the exponential for T in the second part.
Sir, velocity is LT minus 1 or 2?
Minus 1.
Yeah, then
Good, Isra. Now it's correct, Safan. Good, Simaira. Try to solve for the second one. Good, Isra. Good, Simaira.
So
Yes.
I have a doubt. How do we know that when we shift the exponent from numerator to denominator, if the exponent will become negative or not? Like over here, it's not becoming negative, but generally it becomes. So
Just see, if you have to calculate any of the quantity x, which is related by some y over z, there will be dimension for this particular y and there will be some dimension for this particular z. So this particular z will not shift to the other side. We have to put the dimension as it is. So when we bring this particular part to the numerator, its exponential would change to -1. Okay. But in the same expression, x is equals to y divided by z. If you have to calculate this particular term y, so you have to shift this particular z to the other side. Since it is in denominator, so on going to the other side, it will become z times of x is equals to 1. Now you have to put the dimension of these two parts. Now these two terms are in numerator, so you haven't shift or change the exponential of each part to obtain this particular y. Okay.
okay, sir. Thank you.
So it depends upon whether you have to simplify that particular equation first, and then you have to put the dimension of each part. Next, just try to solve if b is equals to alpha divided by beta log alpha times x divided by e. In this expression, P is defining you nothing but pressure, X is displacement, and E is energy. Using this, find dimension of alpha and beta. Okay. So first of all, how to approach this problem? So just see this whole part. It is nothing but log of any number. As we have already discussed, log of anything like this would represent you nothing but number. And for number, it would be dimensionless quantity. So just equate it to 1 and try to obtain the rest of the part which is unknown in the expression. Okay. Is it clear, Safan? Samara?
yes, sir.
Okay,
Yes,
try to
sir.
solve. So just see in this particular expression, you have to just alpha into x divided by e, equate it to nothing but 1. Since in this particular expression, you have to calculate this particular alpha. So you should just tell me what is the first step we have to do to try to obtain this particular alpha. We have to first shift these two terms to the other side so that we can easily solve for this particular alpha.
Yes, so we'll shift the e to the right side.
So since it is in denominator, on going to the other side, it would be in numerator.
Numerator,
And similarly for x, it would be in
the denominator.
good. Now put the dimension of each part and try to solve.
Okay.
Good, Samaira. Good, Yusra. Good, Safan. Now just see this whole part, log of any number. This whole part would define you nothing but any number. A number is any dimensionless quantity. So we can neglect this whole part. So what we're left with, P is equals to alpha divided by beta. Is it clear?
Yes, sir.
So in this expression, we know the dimension formula for P, which is pressure, and we have already solved for alpha. Just put them and try to solve for beta. No, Yusra, just check once again. You have to solve for this particular beta. So shift it to the other side. So it will becomes P times beta is equals to alpha. We have to solve for this particular beta. So put this particular P to the other side. So on bringing to the other side, it will becomes alpha over P. Now put the dimension and try to solve. Samara, check once again. Safan as well. Try to solve this expression. Since you all have solved for this particular alpha, it was nothing but mLt to the power minus 2. Safan, check your answer once again. Yusra, you also check. There is some little mistake. Dimension formula for P is nothing but m L to the power minus 1 and T raised to the power minus 2. Now it's good, Safan. So Myra, have you solved? Good. Yusra? You are again doing the same mistake. Just see, here we have alpha, for which we have calculated this particular value. So just put it mLt to the power minus 2. In denominator, we have P, which is nothing but pressure. Good. So it would be mL to the power minus 1, T raised to the power minus 2. This m and m cancel out. This T and T stay cancel out. Since this L is in denominator, on bringing it to the numerator, it will become L to the power 1 and L to the power 1. So it will become L to the power 2. Is it clear to everyone?
Yes, sir.
Yes, sir.
Safan, any doubt?
No, sir.
So we have just defined how to solve on the basis of principle of homogeneity different problems regarding this. So this is all the basic concept regarding this particular dimension. So we'll just stop here. In next class, we will start defining you application of dimension analysis. There are mainly 3 types of application. First, to check the correctness of any equation. Next is to convert the unit from one system to another. And third one is to deduce relationship between different physical quantities. Okay? Till then, try to solve all the problems which we have discussed in this class and try to solve your assignment. Okay? If you
Okay,
feel
sir.
any problem, try to take one extra class with me and to solve your queries. Okay, Safan?
Yes, sir.
Okay then. Okay then,
Sir,
take care.
Thank you,
Yes,
sir.
sir, class was till 6, right?
till 6. I think it was till this time.
Okay, sir, no problem. Thank you, sir. Thank you.